This is lesson 7.4, part 1. We're going to talk about the properties of rectangles. So a rectangle is a type of parallelogram. So that means it has all of the same properties that regular parallelograms do. So both pairs of opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. But rectangles, because they are more specific, have additional properties. So a rectangle has 4 congruent angles, or 4 right angles. And in a rectangle, the diagonals are congruent. So the whole length of AC is the same thing as the whole length of BD, as well as each individual piece since they were bisected. So all 4 little pieces of the diagonal are congruent. In example 1, we're going to find the measures in the rectangle. So we know that all of these are the same. So if that's 15, these are also 15. We know opposite sides are congruent, so that's 27. And then the only thing we don't know are the sides here, AD and BC. So we'll save that for last. For right now, we can find AC. AC is this whole length here. That's 30 because it's 15 and 15 together. BD, it's a different diagonal, but still 15 and 15 together is 30. BE was just 15. AB was opposite the 27, so that's 27. So now our last one, BC. I'm going to look at a nice big right triangle right here. And I know in this right triangle that this side is 30 and this side is 27, and this is the side we don't know. If you recall from much earlier in the year when we were doing the distance formula, we also talked about Pythagorean theorem. A squared plus b squared equals c squared. So that would be x squared plus 27 squared equals 30 squared. So if you remember, we're going to do 27 squared to get 729. We're going to do 30 squared to get 900. We'll subtract 729 from both sides. So I get 171. And now to get x squared to become x, we're going to take the square root of both sides. And I get x is about 13.07669. So we'll say 13.1. So BC is 13.1. Right? I knew that this was a right angle because all the corners of a rectangle are right angles. So I can use this right triangle. So you can try this one. Pause now if you'd like. Answers posted on Google Classroom. For example 2, I'm now dealing with the angles. I know that these whole angles are 90. This is 64. Next to 64 would be a linear pair, right? These 2 angles here and here are a linear pair. So 180 minus 64 is really 116. So this angle is 116. Vertical to that was 64, and this was 116. The other thing I know is technically, since these are all congruent, these are isosceles triangles. So the 2 angles in here are the same. So what I would do is I would take the 64 away from 180 to get the 116, and then I would divide it by 2 to find out what each of those angles is. So this one is 58 degrees, and this one is 58 degrees. Same thing's going to happen across in the other triangle. And then these bigger triangles, if I took the 116 away from the 180, I got 64 divided by 2, I get 32. Or I could have said, well, if the corner is 90 degrees and I know 58, 90 minus 58 is 32. So everything is filled in here. I can now answer all of these. So x, w, y. X, w, y points to the 58. Y, x, z points to the 32. W, V, Z points to the 116. X, W, Z is the whole corner. So that's 90 degrees. And X, Z, Y was this corner down here. That was another 58 degrees. So here's check-in 2. Try that if you'd like. Pause. Answers posted on Google Classroom. For example 3A, we're given the length of RT and we're given the length of US. So we are given the two full diagonals. Since the diagonals are congruent, I can set them equal to each other. So we're going to take 5x minus 14 and set it equal to 2x plus 10. So we'll take away 2x. We have 3x minus 14 equals 10. Add 14. So now we have 3x is 24. And when we divide by 3, we have x is 8. This asks us to find VT. VT, if we look at where this is in the picture, only goes from here to here. So it was half of RT. So I'm going to plug it back into RT. So we have 40 minus 14 is 26. So if this whole thing is 26, then VT is 13. Here's another example. In this one, we're given VW, which is just half of a diagonal, and SU, which is an entire diagonal. So really what's happening here is this entire diagonal is equal to double, right? Because there's two red ones here, 2 times VW. So we're going to set up this equation and solve. So SU was 16x minus 12 equals 2 parentheses VW, which was 9x minus 11. So this is going to require us to distribute. So we get 18x minus 22. We'll take away our 16x. So we have negative 12 is 2x minus 22. Add the 22. So 10 equals 2x. And we divide by 2, we get x is 5. This is asking us to find WT. WT is the same thing as VW. So I'm going to plug my x is 5 back into the VW. So we have 45 minus 11, so WT is equal to 34. Here's one for you to try. Pause, check your answer on Google Classroom. For example 4, it asks us to find angle BCE. So they want this angle when we're done. But what we have are these angles, which, because they're in a type of parallelogram, are alternate interior angles and are therefore congruent. So we know that 7x plus 5 is equal to 11x minus 3. If we go ahead and solve our equation, 5 equals 4x minus 3. Add our 3, 8 is 4x, and x is 2. I'm going to plug it back in here for this angle. So that's 11 times 2 minus 3. 22 minus 3 is 19 degrees. If we think about what's true about these two angles together they were a right angle. So 90 minus the 19 means that the measure of angle BCE is 71 degrees. Here's a problem for you to try. Pause. Check your answer on Google Classroom. All right, example 5, we want to find angle JHI. So what we're looking for is actually alternate interior with this angle. So when we're done, we'll plug it back in this one. But for now, I'm going to treat the fact that I have a right angle in the corner to know that the sum of these two angles would be 90. So we're going to add up 3x plus 2 and 12x minus 17 and set that equal to 90. So combining our like terms, we have 15x minus 15 equals 90. When we add 15, we'll have 15x equals 105. And when we divide by 15, we get x is 7. So like I said, these are our alternate interior angles, so they're congruent. So I'm going to plug it back into the 3x plus 2. So it's going to be 21 plus 2. The measure of angle JHI is 23 degrees. So the final one for you to try is here. That is the end of the first part of 7.4, properties of rectangles.